Okay, so the question was, when do we use the slide method? So this is a type of factoring. Okay, so and remember, using the quadratic formula is not factoring. All right, so that's just a formula you plug in, and it spits out a result. But the slide method is a form of factoring. All right, and it's a method that is so much easier to use than another method maybe if you learned in the past. But if you like to use the other method, that's fine. You prefer that. Whatever you learned in the past, not using the quadratic formula, then that's fine. Okay. So in this case, um, pause here for a second. Okay, so what's the difference between this one, say, another trinomial, such as, oh, x squared minus 6x plus 9, right? Well, the difference is the leading term here is 1, okay? This one is a leading term 1, all right? And then we can just do straight factoring here. We don't have to use the slide method because we just need to find factors of 9 that will give us minus 6, right? So that will be either 1, 9, and 3, 3, okay? And of course, we have to um, consider the plus and negative, right? So in this case, this will be like x minus 3 and x minus 3. And let's say that's equal to 0. Okay. So again, I didn't have to use the slide method here. And again, the reason why is because the leading term here is a positive 1. All right. And then just set these both equal to 0. And then this will give us x equals 3. Okay. Now, in this one here, the leading term is bigger than 1, right? So this is 2. So any number bigger than 1, then you would have to use the slide method. And the slide method is, remember, is you take that 2 and you multiply it to the back. And that gives us x squared minus 13x minus 14 equals 0. And this is where a lot of students mess up on is they're like, oh, I'm good, and they go straight here. Okay. So, but which is fine, okay, but they forget to do one step after that. So in this case, um, the factors of this will be x minus 14 and then x plus 1 equals 0. And this is what I'm saying. They go from here and they start solving it and they said they're done. So, and that's a big error because since we had multiplied by 2, we have to divide by 2. So we divide this by 2 and then divide this by 2. And we only divide the numbers and not the one with the variable. And then we reduce. So this becomes x minus 7. And this one I can't reduce any further, so I need to put that to the front, the 2 there. So that becomes 2x plus 1 equals 0. Okay? And then I just set them both equal to 0. All right, so then again, this gives me x equals 7, and this gives me x equals negative 1/2. All right, and then these will be my my answer for this question. Okay. All right, so again, when do you use the slide method? We use the slide method when the coefficient here is bigger than 1. Okay, hopefully that helps. Okay, so the question was, what's when you see this problem, say it's happened, you see it on the test, how do you solve this? And what some of the question or some of the concerns was like, well, how do I start this? Do we multiply by the conjugate? Do we do the LCD? How does that, how do we start this problem? And that's a great, question. So the conjugate, I'm going to address that. The conjugate is only talking about when you're doing real number, when you're doing imaginary numbers, right? So if it was like 5 over 3 minus I, then that's when you do the conjugate. You don't do the conjugate on here. Conjugate is when you have the I. Okay, you're trying to get rid of the I in the denominator. Okay. This one here is you're trying to solve for t. All right. So, um, so that's the biggest difference. So we only do the conjugate in this situation is if we are trying to get rid of the I in the denominator. Okay. And in this case, we're not trying to do that. We're trying to get t by itself. Okay. Because again, the difference between this one, this is an expression, and this one here is an equation. This one we're solving for t. This one is we're rewriting this into another expression. In this case, it would be the a plus bi expression. So we're not solving anything here. We're not solving for a particular variable. But in this case, we are. Okay? That's the difference between those two. So, so in this case, again, there's a lot of ways to solve this. All right. I just tell students probably the easiest way to do it is do cross multiplication, right? You've learned that since grade school. So if you have 2 over, you know, 3 equals x over 5, you just cross multiply, right? You just multiply these guys and you multiply these guys. And that gives us 3x equals 10, and then divide both sides by 3, and then x gives you 10/3. That's the easiest way to do it, in my opinion. Okay? I'm going to do exactly the same thing here. I'm going to take the g here and I can rewrite that as g over 1. Because remember, g is the same thing as saying g over 1, right? G divided by 1 is still g. So I recommend just cross multiplying, to be honest with you. All right? So put this g over 1, multiply these guys here, and then multiply these guys here. Okay? So that gives us g times 1 minus t. And this will be c times 1, which is just going to be c. Okay? Now, I kind of do the rest of this a little bit differently than some other people because I'm trying to, well, let's see. What I can do now is I can divide by g, right? Or I can distribute the g and do it that way. It's up to you, okay? Um, Whatever is going to be easier for you. So again, I can do this in two ways. I can divide by g, which gives me 1 minus t is equal to c over g. Or I can distribute the g, and it gives me g minus gt equals c. So it's going to lead me to two different paths. Okay? So if I went this path here, okay, so again, all I did was either divide by g, okay, or distribute the g, okay? So I have a negative here, and we don't like negatives. So what I can do to make my life easier is I can move this minus t to the right side, and then move the cg to the left side. So I can add a t, and that's going to give us 1 is equal to c over g plus t. Okay? And then I can subtract c minus g. C over g, I'm sorry. So then these guys will cancel. And then this is going to leave us 1 minus c over g over t. I'm sorry. 1 minus c over g equals t. And that will be our answer there. Okay? So that's one way. Again, that's just depending on how I'm trying to, how I approach this problem. The other way is this one here. So I can just add, because again, I don't like negatives, so I'm going to make that positive. So I'm going to add a GT, and that's going to give us G is equal to C plus GT, then subtract a C, oops, and that's going to give us G minus C is equal to GT, all right, because again, these C's are going to cancel, and then I'm going to divide by G. Okay. And that gives us this. Now you might say, wait, hold up. That looks different from this one. Technically, it's the same thing. All right. So in this case, what the extra step we can do is divide this by G over G or separate them and C over G. Okay. They mean the same thing. Okay. So I can divide this by the first one by G and then the second one by G. So this here is the same thing as above. Okay. And then I can simplify this a little bit further. G over G is 1, and then I have the minus C over G is equal to T. So we get the same exact answer. Okay. All right. So again, it really depends on how you start it. So, but I recommend starting it as putting it over 1 and automatically I need to cross multiply. That's my suggestion. Another way is to multiply by the LCD and you'll get the same thing and you go through these two different paths. Okay. Hopefully that helps. Okay, so here it says you have a bank a loan out $12,000, part of it at a rate of 7% and the rest at 17%. If the interest received in 1 year total $1,500, how much was loaned at 7%? How much of the $12,000 did the bank loan out at 7%? Okay, so again, the key part here in word problems is organization, organizing the material that they give to you, that present to you. So I always look at it, okay, what are the parts that they're talking about on the left side of the equation? And then what is my outcome? That's always how I view these things, okay? So in this case, we're talking about two types of percent, okay? So we're talking about the 7% and the 17%. So that's going to put here. I'm going to have my 7%. And then I have my 17%. All right. So those are two things they're talking about. And then you have your outcome. Okay. What's the result? What are you trying to get at? Now, since we're talking about loan interest, this is a loan interest problem. So we're actually going to use the formula I is equal to PRT. Okay. So remember, P is talking about the principal or the money borrowed. R is talking about the rate and T is time annually per year. Okay. So that's how I'm going to do this. Okay. So the first part is the principal or the money borrowed. So the bank loaned out $12,000. Okay. So, and again, part of it was 7% and part of it was 17%. So we don't know how much was put in each of these percentages. So one of them has to be X. And normally I just like to put the first one as X, but it doesn't really matter. In the end, again, um, how it's solved, so it might be a little bit different, but in the end, you should get the same result. Okay. So in this case, I'm going to label this X because again, I don't know how much I'm putting in 7%. But um, so whatever I put in here, that means the rest will go into 17%. So that means then, in this case, I would have put in 12,000 minus X, right? So if I put 5,000 in here, there will be 7,000 this one. It'll be 12,000 minus 5,000. Okay? So that's going to be my P, right? That's the principal or the amount borrowed. Now I'm going to work on my R, my rate. Well, this one is 7%, so I can change that to 0.07. And this one is 17%, so I can change that to 0.17. Okay. And this is per year. So that means we're just gonna, we're gonna work on T, which is time, and that's per year. So this is just gonna be over 1 year. Okay. And this one will also be over 1 year. And then we just add them together. And then what do we want to produce? We want to, if the interest received a total of $1,500. So we put it in this much in the 7% account and then this much in the 17% account, and we want the outcome to be $1,500. So that's how much interest has occurred. over that year. Okay. Any question on the setup there? Yeah. All right. And then and this is the hardest part, right? Once you get the setup, then the rest is just doing a little bit of algebra. Okay. So in this case, we're going to have 0.07x. This one, I'm going to distribute the 0.17 to each term. Remember, 0.17 times 1 is still 0.17. So this is going to give us 2040 minus 0.17x. Okay. Then we're going to simplify this. So 0.07 and 0.17 is going to give us minus 0.1x. And we still got the 2040 in the front equals 1500. Okay. And then we're going to subtract 2040 on each side. We get minus 540. Then divide both sides by negative 0.1. Okay. So in this case, we get x is equal to 5400. Okay. And that x is the 7%. And that's what we want, right? How much of the loan did the bank loan out at 7%? Well, it's going to be 5400. So we don't have to solve for the other one because that's what they're asking. They're asking for what is x, right? And that's what we just found out. All right. Now, if they wanted to find out the 17%, then we just subtract 5400 from the $12,000 to get the rest. Okay. Okay, so this one is dealing with the use substitution. How do I know? Well, the first um, clue is I have x to the fourth power, and normally I only have x squared, right? So that means I need to do something creative here to solve this. Okay. All right, um, so the best way to, and plus I have three terms. Okay. If it was four terms, then I would do factor by grouping. Okay. But since this is three terms, I can't do factor by grouping. Because factor by grouping, I want to have two terms in the front and two terms in the back, and I can't do that with this one. So that means I gotta do the U substitution here. And then how do I know, what do I substitute? Well, the center term, right, this one here, the x squared, is going to tell us what we need to substitute. Okay, so in this case, it's going to be x squared, right? So u is going to be x squared. And we use this a lot in calculus, right? We do a lot of substitutions, okay? So in this case, then, I'm going to rewrite this as 26 times x squared, okay? And then this one here, I'm going to rewrite as x squared raised to the square, right? So it's, remember, a power raised to a power, you multiply. A power raised to a power, you multiply. So 2 times 2 is going to give us 4. Okay? All right? So, and of course I have plus 25 equals 0. Right? So now what I need to do is, I said that u was equal to x squared. So anytime I see an x squared, I'm going to replace that by u. So this will be u squared minus 26u plus 25 equals 0. Now this is something I know how to do. This is a power of 2, and I can factor this. So the purpose of u substitution is to allow us to solve the problem, okay? Because if not, then there is another way, but I haven't showed you that. But the purpose is, the objective is of the course is learning how to use u substitution, and that's what I'm trying to teach. Okay. So anyway, so this is the big part here. So going from the original, rewriting it in this format, and then having this u squared minus 26u plus 25. So again, this is something I know how to factor. All right, so this is going to be what? U minus 25 times u minus 1. Okay. And then I'm going to just set them both equal to 0. okay? And then solve. So this will give me u is equal to 25 and u equals to 1. Now I have to be careful because I'm not completely solved here yet because this is u and I want x. So I got to replace x squared and plug that back in where u is. So this is going to be x squared equals 25 and x squared is equal to 1. So then I can take the square root on both sides. So x will give us plus or minus 5, and here x will give us plus or minus 1. Right? And then I have how many answers here? 4. And that is a big indicator, hey, I'm on the right track. Because here at the beginning it says it's a power of 4. In the end, I should have 4 solutions. Maybe a combination of real or sometimes imaginary. But in this case, we're looking for real solutions. So if it gave us an imaginary, we wouldn't use that. Okay? All right. The biggest part is how do I start this? What is my goal? What am I trying to do here? So again, when you see a complex problem or imaginary problem, especially if it's in fraction form, your goal is to get rid of the I in the denominator. So your goal is to eliminate the I in the denominator. Okay? Okay, because we need to write it in A plus BI form. We need to write it in this form, the answer. So we're rewriting this expression. We're not solving anything, right? We're not solving for I. Right? We're not solving for a particular variable because this is an expression. If it was equal to 0, then yes, we would solve for a particular variable, but we're not doing that. We're just rewriting it in a way um, it can be written as A plus BI. And in order to do that, we have to get rid of the I in the denominator. All right, so what do we do? Well, the very first step is we need to multiply by the conjugate. That's the very first step, multiply by the conjugate. And the conjugate just means the difference of squares, right? The conjugate is the difference of squares. Okay? So again, if we have x squared minus 9, that will be x minus 3, x plus 3. Okay? So this 9 can be written as 3 squared. So that's the same thing with the formula for the difference of squares. It will be it would be a squared minus b squared, and that would be a minus b times a plus b. Okay? So what does it mean by the conjugate? Again, the conjugate means if I have a minus b, okay? If I have a minus b, the conjugate will be a plus b, the opposite of that, and vice versa. If I have a plus b, the conjugate will be a minus b, right? So remember that. So in this case, again, I don't care about the top. I'm not doing that. I'm worried about the bottom. That's what I'm focused on. Okay? So I'm going to multiply this by the conjugate of the bottom. So I have 4 plus I, so that means I need to multiply 4 minus I. All right? And this is a common mistake students make is they only do it once. Okay? You have to do it the top and bottom as well because it's like multiplying by 1. Okay? If you don't do that, then the problem, you just change the expression. All right? We have to do it twice, top and bottom. Okay? And what I do is I like to do my scratch work. So I'll put this in the side. So I have 5 minus I and then 4 minus I. And this one I'll have 4 plus I and then 4 minus I. I like to break them down. Okay, so in this case here, we're going to distribute that 5. So I have 5 times 4 minus I, and then minus I, 4 minus I. Again, I just do this a little bit differently, but it basically is the 4 method, okay? Okay, so that gives us 20 minus 5I minus 4I, and then plus I squared, okay? Now, I squared, remember, is equal to negative 1. So this is going to give us 20 minus 9I minus 1. Okay, and then so we didn't combine like terms. So that's going to give us 19. 20 minus 1 is 19. So this would be 19 minus 9i. All right, so that's what I'm going to get on top. We're going to get 19 minus 9i. Okay. Now on the bottom here, okay, the 4 plus I minus 4i, I can go through the same process as distributing those terms to each one, or I can just use my formula, right? So this is my a plus b, and this is my a minus b. And the formula says, hey, just take a squared minus b squared. What's my a? 4, so that would be 4 squared. What's my b? Well, that's just I, so that would be I squared. So that's going to give us 16 minus what? I squared is negative 1. So that's going to give us 16 plus 1, which is 17. Okay? So now we worked out the bottom and we just say that's 17. So you can leave your answer like this, or you can rewrite it as 19 over 17 equal minus 19 over 17i. It doesn't matter to me. Okay, so this one is talking about the open box. So it's an open box to be constructed from a square piece of sheet metal by removing a square of the side 4 feet from each corner and turning up the edges. If the box is to hold 256 cubic feet, what should the dimensions of the sheet metal? What is the length of a side of the square piece of sheet metal? All right. So the question I posed was, what is causing confusion on this problem? Because again, this problem is missed a lot. So I'm trying to have a better understanding so I can try to explain it better. So again, we know we have a flat sheet, right? And from this flat sheet, we're cutting 4 by 4 feet on each corner and then forming a box. And so now we're going to from a two-dimensional space to a three-dimensional space. Okay? And that three-dimensional space deals with volume. Okay? And so we need to use the formula for the volume, which is V is equal to the length times width times height. So this is what I'm trying to aim at. This is my goal. I need to figure out what do I put in for each of these variables, right? The V I already know, right? Because it says it holds 256 cubic feet. I already know that. So that should not, should be no brainer. I need to put 256 for V more than anything, right? The next part is, okay, I need to figure out what I put it for length, width, and the height. And they give us a diagram here. On the test, they might not give us a diagram. All right. So I'm actually going to rewrite this or redraw this. So we have our square, our sheet metal. Okay. And what we're doing is we're cutting out little corners, square corners, right? And I know the square corner are 4 feet by 4 feet. Use a different color here. Okay, so this is 4 feet by 4 feet. Okay, and it's all like that everywhere around, right? All the way around. It's 4 feet by 4 feet, 4 feet by 4 feet. Right? So that means I'm cutting that out. I'm taking all these corners out. Right? Get rid of those. Getting rid of those. Getting rid of those. Okay? So that means then I'm going to have just this white space, this space right here, right? It's like a plus, a little plus sign. All right, that's what's going to be left over of that sheet metal. And so I'm going to be folding this thing, right? Right here. So I'm going to be folding it here and folding it here and folding it here and here, right? So I'm going to fold those sides there. So that'll be standing up now to form an open box. Okay. So when I form the open box, it's going to look like this, right? Again, this is not drawn to scale. Okay. Right. So we have an open box. So we need to figure out, okay, what's my length, what's my width, and what's my height. So it has to come from here. Do we know the length and width, or I should say, the base and the height of this rectangle? I'm sorry, this square sheet of metal. No, right? We have no idea what it is. Okay, so right, I don't know where it is. It's X by X. I have no idea. It's X by X. Okay, but I can deduce it by what? Well, what's going to be if these sides here are 4 by 4? What's this edge going to be here?
X minus 8.
X minus 8, right? So I'm talking about this, right? Use a different color. Maybe highlighter. Yeah. So I'm talking about this part right here. What's this edge going to be? Well, that's going to be the whole thing is X, and I'm cutting out 4 inches each, or 4 feet each. So that means this part here is going to be X minus 8. All right? Which corresponds to this right here, where the box was cut or folded. Right? So that means this piece here is X minus 8. Does that make sense? Okay. So that means then this side is X minus 8, and then this side is X minus 8, and this side is X minus 8. So all the way around is X minus 8. So what's going to be the length and width here? X minus 8, right? This is going to be X minus 8, and this is going to be X minus 8. The only thing that's going to be different is what? Our height. What's height going to be? 4. Yeah, exactly, right? Because that's where we folded it up. When we stood up, that the side panel, it becomes 4, right? It's 4. The height is 4. Are we okay with that? Okay. This is the kicker part. This is the part where students just like, I have no idea. Okay. So now we have all that information. Now we can just put it into our formula. So X minus 8, X minus 8, and then times 4. Okay. All right. So we want this here. This is our goal. We need 4 parts, the left and 3 parts on the right. So remember that. We need 4 parts. If we don't get this here, this part, then it's going to be wrong. Okay? So we need to get that set up, the 4 parts. All right. So now I have X minus 8. So that means I can rewrite that as X minus 8 squared, or I can multiply it out. Doesn't matter. Okay? And this is equal to 256. All right, and then I'm going to divide both sides by 4. I'm writing too big here. I'm going to run out of space. So I have X minus 8 square. All right, and 256 divided by 4 is going to give us 64. Then I'm going to take the square root on both sides. Okay, and this is the part the students mess up on as well. The square root of 64 is not just 8, but it's going to be plus or minus 8. Okay. Why? Because we have a power of 2. That means I should have 2 possible solutions. Okay. So then the radical and the square cancel, giving us X minus 8. Okay. So then we're going to have 2 equations. Right? That's what you're going to need. Okay. So we're going to have 8 equals X minus 8. And the other one's going to be minus 8 equals X minus 8. Again, you're going to have 2 equations because we had the power of 2. Okay. So in the bottom here, I'm going to have add 8 to both sides. That cancels, leaving me 0 is equal to X. This one here on the top, okay, that's going to be plus 8 plus 8. So that's going to give us, that cancels, giving us X is equal to 16. Okay. Now, of course, one of them is not going to work, right? And which one will that be? Exactly. The zero, right? This one is not going to work because you put zero in here, that's going to be 0 minus 8 because -8. Can you have a negative distance? No. Or a negative measurement? No. Okay. So that means our solution has to be 16. So I do 16 minus 8, 16 minus 8. All right. So this can be 8, 8, and 4. So if I multiply all that out, 8 times 8 times 4, that should give me 256. So that's one way to check whether I got that right or not. But the question is asking is, what's the length of the side of the square sheet of metal? Well, this is 16 and this is 16. So this is going to be 16 feet by 16 feet. That's the answer. Okay, because that's what it's asking. Right? So if we had like 2 over a radical 5, right? To get rid of the radical, we multiply the top and bottom by the same radical. And that will give us 2 radical 5 over 5, because radical 5 times radical 5 is radical 25, and the radical 25 is equal to 5. Okay? All right. So we're going to do exactly the same thing here, but in this case we have 2 plus, so that means we want to multiply by the conjugate to get rid of that. So again, the goal here is to eliminate the radical in the denominator. Okay, so we're going to multiply by the conjugate, so that'll be 2 minus radical 3, and then 2 minus radical 3. Okay, so we're going to have, again, I'll do my scratch work here. So we have 3 times 2 minus radical 3, and then 2 plus radical 3 times 2 minus radical 3. Okay. I like to just leave this side alone. I don't do anything unless it's going to help me cancel something out. Okay, or help me to um, improve what I have. But this one I have to throw this out. Okay, so this is going to give us 4 minus, so again, I just distribute to each term. So it's 4 minus 2 radical 3 plus 2 radical 3 minus radical 3 times radical 3. Okay, so so in this case, these are going to cancel. And I have 4 minus radical 9, because radical 3 times radical 3 is radical 9. And radical 9 is just 3, isn't it? So it'll be 4 minus 3, which is 1. All right. So in this case, the top I'll have 3 times 2 minus radical 3. And the bottom is just going to be 1. Okay. So then our answer here is 3 times 2 minus radical 3, or I can distribute the 3 and have 6 minus radical 3. 6 minus 6 radical 3. So here. Okay, so it's 6 minus, and it should be 3, not 6 minus 6. So it'll be 6 minus 3 radical 3. Thank you. Okay, so I want to do a problem dealing with absolute value. So I'm actually going to rewrite this to kind of just um, prove my point, or um, try to identify the error. Okay, so let's say we have, um, right, I'm going to rewrite it as 2 plus the absolute value of x squared plus 3x minus 2 equals 4. Okay. All right. So before I start this, I need to get the absolute value by itself. Okay. So this is 2 plus the absolute value. So that means I need to get rid of the 2 plus. In order for me to apply the theorem, I need to get rid of, I need to get the absolute value by itself. So I'm going to minus 2 on both sides. Okay? So that's gone. So that gives us x squared plus 3x minus 2 equals 2. Now, if this was being multiplied by 4, then I would divide by 4 on both sides and do that. So whatever is being multiplied, subtracted, whatever it is that's attached to that, I need to get rid of those. Okay? Now I have the acid by itself. Okay? Now I can apply the theorem. Right? The theorem says, hey, if you have if you have um, an absolute value, you're going to have two separate equations, right? Remember, the absolute value just means how far away am I from the left side of zero and the right side of zero. Okay, so in this case, I'm going to have um, x squared plus 3x minus 21 equals -2. And then the other one, I'm going to have x squared plus 3x minus 21 equals +2.
Isn't that -2? And that's just the absolute value, not a 1.
Did I put 21? Sorry. Thank you. Okay. Two. Oops. Okay. All right. So again, I'm going to have two separate equations. All right. So again, that is the most important part, and that's the most missed part of the thing. Because students starts to like put it in this form without getting the absolute value by itself. And I mentioned it over and over and over and over. Get the absolute value by itself first. Okay. All right. So then I can start solving this. So I'm going to um, add 2 to both sides. I get x squared plus 3x equals 0. Okay. And then I can factor out an x. So that gives me x plus 3 equals 0. So x equals 0 and x plus 3 is equal to 0. So x equals -3. So I've got uh, some answers here on the left. And then do exactly the same thing on the right. Okay. So in this case, I need to get equal to 0. So I'm going to subtract 2 here. So that gives me x squared plus 3x minus 4 equals 0. Okay. Then I factor that. So that's going to be x plus 4 and then x minus 1 equals 0. So I'll get x plus 4 equals 0 and then x minus 1 equals 0. So that gives me -4 and +1. Okay. All right, and I'll have 4 answers because I have here on the left side x squared, so it spits out 2 answers. And on the right side, I also have another x squared, so it spits out the other 2 answers. Okay, so again, I'm going to write this in 2 ways. So let's say we have -2x minus 5 less than equal to -9. Okay, and we just have um, say just 2x minus 5, and it's equal to less than equal to um, 9. Okay, all right. So again, if anything is being multiplied, subtracted, whatever, to the absolute value, I need to get rid of that. So in this case, I have a -1. So that means I need to divide both sides by -1. So divide this by -1, divide that by -1. So the -1 cancels, and then we're left with the absolute value of 2x minus 5. And then since I divided by a negative, so if we multiply, divide by a negative, then we need to change the inequality, right? Flip it. So it'll be greater than or equal to positive 9. All right, so again, that is a key part there. All right, and then I just look at my format sheet, and if it's greater than, right, that means greater than or equal to, I have a greater, right? This is a greater. That's a great or, right? Play on words. So that means I'm going to have two separate equations. So I'm going to have 2x minus 5 is less than or equal to negative 9, or 2x minus 5 is greater than or equal to positive 9. Okay? I'm going to have that. Right? And you have that here in the formula sheet. Okay? So use that. Says it right there. If it's greater or equal to, you're going to have two separate equations there. Okay? All right, and then I just solve. Okay? So you can do that, but anyway, I just want to stress that out there. Actually, let's keep going on this. So I'm going to have add 5. That gives me 2x is less than or equal to negative 4. Divide by 2. So x gives me less than or equal to negative 2. Okay? And again, I still have or here in the middle. Add 5. We got 2x is greater than or equal to 14. Divide by 2. So x is going to give us greater than or equal to 7. All right, so then I'll say, okay, now I want you to graph your solution. All right, no problem. So I'm going to have -2, a 0, and then a 7. You want to at least plot 3 points. All right, so in this case, I have a -2, and it's less than or equal to, so it'll be filled in circle going to the left. This one is at 7, and it's also filled in because it says greater than or equal to. So that's going to go to the right. Right? Again, that only works when the variable is on the left side. So this is when it says graph your solution, this is what it is. That's my solution. It doesn't look like a linear, right? Because I get that. They'll draw something like this or like that. This is not a linear, right? So your graph should be on the number line. Okay, now about this one is going to be totally different. Okay, this one's going to be a different one. Okay, um, all right. So this one, again, if there was anything, um, let's say we had I don't know, a 4 or something, 4 plus something. Okay, so then I would um, actually let's put a 3 there. Say 3 plus something, right? So I need to get the absolute by itself. So I'm going to subtract 3 on both sides. Okay. And then that will give me 2x minus 5. And that'll be less than or equal to 6. All right. So this is a less than, right? This is less, and I put than, right? Going to play on words. So that means if I less than, then that means I'm going to have one equation, right? So I'm going to have -6 less than or equal to 2x minus 5 less than or equal to positive 6. And means I connect them together, or means I have two separate. Okay, and then I just solve. So +5, +5, +5. So that gives me -1, and then 2x, because again, this cancels, and equal to 11. 6 plus 5 is 11, then divide both sides by 2. Okay, so we get -1/2 less than or equal to x less than or equal to 11/2. And then that will be our answer there. Right? And then if we were to graph that, then I would have, -1/2, put a 0 in the middle, and 11/2. Okay? And it's going to be, again, closed circle, because it's less than or equal to, closed circle, and all the numbers in between. All right?